So that is so fun. It's working, going live. Just wait. Okay, students. So I put this. And I hope that now everything is okay. I'm audible also, yeah? You see, we completed Snell's law. So only we have completed Snell's law. And apparent depth, and Sonali Pathak says we have completed apparent depth and real depth numericals. Depth. Okay, cool. We'll revise it again. Is it fine? Okay. We'll revise and then we'll start the critical angle, then reflection through the spherical lenses, and then we'll see what? Then we'll see the lenses. Okay. Is it fine? Yes. What about Anu and Sonali? Is it fine? Yes or no? Yes or no? Yes or no? What do you say? What do you say? Yes or no? So I hope it's cleared for you. Okay. So one more student have joined. Let me see who is this. Anshuta have also joined. So cool. Okay. So now we all will study together. But 5 students only. What about other students? What about other JNV students? No. Okay. Okay. No issues then. If there are no, still will start the class. I'm audible and slides are visible. No. Yes. I'm audible. Slides are visible. Last time I'm asking yes or no. Or you can send emojis like or cut. Okay. Yes. 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 ठीक है. So, see, this was the thing which we have completed. You can see this thing. Okay. This was the thing which we have completed in the previous classes. है ना? Apparent depth, normal shift. ठीक है? After this, we have seen lateral shift. I mean, this thing we haven't done actually. Lateral shift, है ना? नहीं देखा था. We haven't completed. So this, okay, critical angle. Now let's see. So I have to now go. ठीक है? So let us start with the speed. So let us see, students. If you are feeling any audibility issue in between, please text me. Okay. कोई भी audibility issue हुआ in between, you can text as fast as you can. Okay. So let us start this. Yeah, this was the topic. No. If you see it, let me take this color, yellow color. Yeah. Let us revise it again. Okay. So are you ready for the revision? Okay. Apparent depth and the normal shift. What's the time? The time is here. It is 309. Okay, it's fine. Okay, you want me to start the recording also? No, so record of the cloud is also started. Okay. So let us revise. Here, fish is here. This is the fish. This we know this thing key. Voice is fluctuating means there may be some network issue, but it will be fine. Okay, don't worry about this. Maybe some network issue. Okay, now it is fine. Is it fine now? I hope this is fine now. Okay. So let us see. This is the original position of the fish. Original position of the fish. Okay. This is what original position of fish. And we know this thing. I've already highlighted, but I'll highlight it again for explanation. Okay, you can see yourself. Hold on, one student is texting me something. What's that? Yes, sir. So you can see see this thing yourself here, that this is a fish, and the ray is going from this fish like this. Okay, and when it is incident at this point, if you focus at this point, this is what? This is a point on this boundary which is separating two mediums. Okay, we know this thing. This is what? A point on this boundary which is separating two mediums. What are the mediums basically? The mediums are this, that is water and air. This is air and one say 1, this is water, and 2 says 1.33. We know this 4 by 3 and not 1.5. 1.5 is for what? It is for 1.5 किसके लिए होता है students? 1.5 is for glass. So we know this thing, when the ray will pass like this is a normal to the surface. Of course, when the ray passes from a denser medium to a rarer medium, it bends away from the normal. Okay. It bends away from the normal. So now angle of refraction. See, if there is a voice fluctuation, you can start from the okay. I mean, maybe today, maybe, a lot of network error is here. So can't be done in this. I mean, I'm not saying just wait. Okay, it will be fine. Okay, so hold. Let me do something here. Okay, now the voice is fine. Is the voice fine now? Now the voice is fine. Okay, sir. Cool. Okay, Sonali, that's fine. So what I was saying, the ray, because I've stopped the recording and a network ke karan sometime it happens. So when the ray is going from this is deviating away from the normal. You can see this is a law. This is due to the reason what? The law of refraction. Okay, refraction. When the ray passes from this medium denser to rarer, it is deviating away. I'll say here R is greater than I. We know the reason, denser to rarer. Okay. When this ray is extended back virtually like this, I'll get an image of the fish, which is not a real image. Okay. So which is what? Which is actually the image, not the real object, which is actually the fish. Okay. But if someone will ask from me, hey, you boy, green shirt boy, tell me this thing, that what is the depth of the fish inside the water? To you, in your eyes, the ray which is coming is this ray, this ray, this ray. When extended back, it will meet this image, which is not the original object, that is the fish. So you will say that the depth of this fish is this much only, which is actually, it's apparent. Apparent means which appears to our eyes, but actually it is not. I repeat it again, which is appearing to our eyes, but actually it is not. It is what? Apparent. Okay. But we know the original is what? Original is this much, that is the real depth. Okay, so we can say, suppose the apparent depth is given by D dash, the real depth is given by D. So we have founded this thing ki D dash was greater or less. What you will say? What you will comment about this D dash? Okay, Jane, them 3 students have also joined to that school. Okay, I'm just asking you a question. What you will comment on this D dash value? Is it greater than or less than D? What you will say? Text stage students, what you will say? Is it greater or less? Anyone? You can text in the chat box. Okay, let me tell this answer. Of course, this D is greater than D dash. We'll comment for this condition. So write this point in your notes, especially. Okay, write this point in your notes. Very good. Anu, that's the right answer. Sonali, that's the right answer. Excellent. So I will say like this, ki when the object, write this point in your notes. When the object is in, we are revising the things, okay? So if the student didn't understood in the previous sessions, so no need to worry. You can just start from here, okay? So see this thing. When the object is in, when the object is in water, okay, when the object is in water or say some denser medium, then what happens? Then the apparent depth, which here I have given by d dash, will be always less than the real depth of the object, okay? But the condition will be reversed, that is vice versa. Condition will be for object is in air medium. Right here is in air or rarer medium. Then you will observe this thing, that apparent height in that case will be actually greater than the real height. Okay, so these are two opposite conditions. So if you see an object in the denser medium, it will give you this thing. If you see an object in the rarer medium, this will give you this thing, which are both opposite. This point is clear? Okay. So similar looking example is this photo also, in which what is happening? This is some factory worker kind of person, and maybe he's like allotted some work here. Okay. So many processes, as I've already told in the previous class. Suppose some box is there. Its actual depth is this much, this big one, say capital D. Okay. But when the ray is coming like this is the angle of incidence. Of course, I told you this thing. When the ray passes from a denser medium, here a denser medium is what? Water, to rarer medium, that is what? Air. So it bends away from the normal, where this angle R with which the ray is bending, it is now known as refracted rays. It is not known as reflected ray, it is known as refracted ray. So we'll say R is greater than I, okay? When extended back, it will meet here. So to this person, he will see like this, the object is at this much depth, which is D dash. And we know this thing, this is small, say capital D dash. And we know this thing, this is weak. Apparent means it's appearing to him, okay? And the real condition is this, that actual depth is greater than the D dash. Okay. The actual condition is what? The actual condition is this. D is greater than D dash. Okay, students, is it clear? Is it clear, student? Okay. Okay. Okay, so this was the previous thing. I mean, in the previous classes, we have studied this thing. It's a revision part. So let us move towards the next. Apparent depth and normal shift. This is again the same. Here, what we did on this slide, in the previous class, we did here the mathematical formulation. We did what? We have completed here mathematics part. What was the formula? We know the formula was, in the next slide it's given, n2 upon n1 d dash upon d. So we wrote here like this, ki apparent depth upon real depth is equals to how much? n2 upon n1, that is n2 upon n1. N1 is where the object is, from where the ray is coming. N2 is the refractive index of the medium, where the ray from the object is going. है ना? We have seen these things, no? Earlier also we have seen this thing. Okay. Yeah, that's right. Sonali, your answer is perfect. So again, if you match with this picture, which is just a ray diagram representation. Okay, what is this? This is object. Okay. The rays are coming from the object like this. Okay. It is incident here at this point. Okay. The ray from the object is coming like this. It is incident at this point. We know this thing here, angle of R is greater than angle of I, because the ray is bending away from the normal when it passes from a rarer medium to denser medium. Understood? And when this is extended back, it will meet at this point, which is actually the image of the object. So again, if somebody will ask you, if you're standing on this, see, all the distances will be measured from this boundary. Okay, let me highlight this boundary. All the distances are measured from this boundary you can see on your screen. Okay, students. So again, you will say like this key, actually the object is at depth D, this much, but to your eyes it will appear this much, where this D is greater than, of course, this D dash. Okay. This is the formula you have seen. See, above formula is valid only for paraxial rays. What do you mean by paraxial rays? Paraxial rays, students, anybody can give the definition? Any one of you? Like from JNV, Dimitri, Anshuta, AP, Sonali, like from JNV Raipur students, any one of you, Sneha Ghosh, Mayuri, anyone. What do you say? Paraxial का meaning क्या होता है? See, I've explained during the topic of concave mirror, I told this thing, no. The reflection due to, this is, see, reflection. So when we have studied this topic of reflection, what we studied, कि paraxial rays are rays which are making very small, very near to this axis. Like theta, if a ray is falling like this, the theta angle, you know this thing, when the ray strikes parallel to the axis. No, who's this? Parallel to the axis. Yeah, I mean, you can say very near to the axis. See, if suppose this theta is very small, let me tell you like this. If this is theta, if this theta is like approximately, like d theta, okay, I mean, a value which is like just not, it's just going to touch the zero. So for that condition, we say what? Like somewhat near to it, axis, okay. Parallel. See, even if you're saying parallel, that is anti. If they're anti-parallel, we say 180. If they're parallel, we say what? 0 degree, no? Okay, distance, this is like this, ki paraxial rays are very near to the axis. Suppose in this concave mirror, you can treat the angle to be very, like very small d theta, and you are right, it's parallel, okay. Approximately equals to 0. Distance should be taken from the surface. So this is a second important point for this topic I've already highlighted. So this is a surface yellow color. Distances should be measured, whether the depth or whether the height. We have seen the question also. You know? And N2 I've already given is the refractive index of the medium where the ray is going. So N2 is that. So this I've written, okay, where the ray is going. And N1 is where the ray is coming, where the object is. So object hoga, tabhi to rays will be coming. You know? After this, we have solved this question. So I have solved first question. The answer was this, that apparent depth, suppose a fish is here and the fish may be visible. Suppose it's visible like this. So this is D dash distance. Capital, the real D distance is 36 centimeter. So when I solve it, that is apparent upon the real 36. Distances will be measured from this surface. You have remembered this thing. All of you remember this thing. Distances will be measured from the surface. Okay. So when you will write this thing here, D dash, which is basically apparent fish depth, okay, and D, which is basically the real fish depth, okay. This is the real fish. This is the image. I made a very bad image. No issues. I will write here N2 upon N1. N2 is what? N2 is what, students? You can see the formula again. N2 was this, that is where the ray is going. So here the ray from the fishes will be going in this medium, which is N2. This is 1. Okay, and N1 is what? From where the ray is coming. Ray is coming from the object, which is fish here. So N1 is 4/3 for this. So N2 upon N1. Solve this question. N2 kitna? It's 1. N1 is how much? It's 4/3. So from this you'll get the answer like this. 1 upon 4/3 is how much? 3/4. When you will solve for this apparent, you will get the answer as 36 3/4. It is 27 centimeter. Oh yeah, na students, this question. Yes, negotiation answer is that small angle making. Okay, that's fine. So I'll say like this. D dash here is equals to 27 centimeter. But this D dash distance is from where? This D dash distance is from surface. Okay, this is from surface. But if someone is asking from the bird, so you will add this. अगर कोई bird से पूछेगा, so you will add this distance with the apparent. That is the bird's distance plus the apparent distance, this much. This complete distance of the bird plus this apparent, okay, will give you the net apparent depth from the bird's eye. Okay, it's, we see no eagle's eye, it's bird's eye. Okay, suppose a bird is here. I know from the surface bird ka kitna distance hai, height on at which it's flying. Okay, it's 36 centimeter. So plus the apparent depth D dash, which is equals to 27. So net answer will get like this. From the bird's perspective eye, bird will see like this. It is at the depth of 36 plus 27 starting from the air. Okay, or you can say distance of the fish's image. It is equals to this. This is equals to what? 6 7 is how much? 13, 63 centimeter. Okay, got it? This first question is revised again. I feel that now you must be able to solve this question at any time if anyone gives you. Second question, I've given you homework. Any answer? Second, okay, Sonali, that's good. Second question, I've given you the homework. Any answer? Any one of you? Any answer? Any one of you? Second question. When we reverse this case, now the fish is observing the bird. So at how much apparent distance the bird will be? Any answer, students? Yes or no? Any one of you students? Okay, so I'm giving you this answer. Okay, see, watch it carefully. This is the bird. Okay. Okay, one student have given the answer, 84 answer. Okay, so now we'll see that is your answer right or wrong. Just wait. We'll see that is your answer right or wrong. Okay. See, if you observe it, now suppose the bird, suppose now we are observing the bird. So rays from the bird will be coming like this. Okay, let me draw the rays. This picture is actually showing you the ray diagram of the fish, not the bird. Now I will draw the fresh ray diagram of the bird. Okay. Suppose the bird is coming like this. Suppose the ray from the bird is coming like this. Okay. This is angle of incidence to the normal. And this is the boundary. This MM dash is the boundary separating two medium. You know this thing. Where the inside medium is 4/3 and this is the up medium, that is 1. Okay. So no need to write the subscripts here. Just write the refractive indices because now it will be shifted, you will see in the formula. Okay. So it's given that the bird's actual height is 36 centimeter from the surface separating two mediums, MM dash, which is a boundary surface. Okay. So see, we know this thing when the ray is passing from a rarer medium, which is here air, to a denser medium, which is here as what? Water. It deviates towards the normal. So now it will deviate towards the normal. And suppose a fish is here. I have to draw the same diagram again. Suppose this is a fish. So fish will see like this. This is R angle. Now the R angle is less than the I angle. Or I angle is greater because it is deviated towards the normal now when entering from the rarer to the denser. But if we see the previous cases, we know this thing. There the picture is this, the R angle is greater than I. Because when passing from a denser medium to a rarer medium, it deviates, sorry, when passing from, denser to a rarer medium, it deviates away from the normal. Okay. Just hold one thing here, some mistake is there maybe. It's not rarer, it's denser. It's denser, it's rarer. That's why it's bending away from the normal. R is greater than I. Okay. Now let us apply this thing here. So here we are getting I is greater than R because it's from rarer to the denser, deviates towards the normal. So when this ray is extended back, let me show you with the blue color. When this ray refracted in the denser medium is drawn back, it will meet here. So I will say the bird's new location will be this, or the image of the bird will be here. Okay, this is the bird's location. Now we'll say the apparent height of the bird is now greater. Okay, so apparent height will be at this level. So this is the apparent height h dash. This is, of course, we know it's greater than the real, which is actually equals to 36 centimeter, which is given in the question. So now they're asking from us to find this h dash, the apparent height of the bird. I mean, to the fish will see like this. This is the actual height of the bird. Okay. Fish will see what? H dash is the actual height, but we know the actual height is how much? 36 centimeters. Okay, let us see. So I'm applying the formula. Now the formula will be like this because the mediums are separated now. Initially, you were observing this thing with respect to the bird, okay, in this rare medium. Now you're observing this picture with respect to the fish. That is, you are now in the denser medium. So I will write like this. Apparent height. The formula will be this. Remember always, if you're able to understand this case, it will be easy to solve other cases which are similar to this. Apparent height upon the real height now will be what? We know this thing. Apparent matlab, apparent, initially apparent, see, Akansha, you please don't do here any kind of annotations. Apparent matlab, what is apparent? Apparent matlab, when initially you were in the what? Rarer medium. Okay, now the apparent is where? It shifted. Now you are observing a bird, okay, and you are the fish. So we'll write here for this. That is, now I will change this refractive indices. That is, now it will become like this. The object is what? Object is this bird. The object is bird. Okay. So N2 upon N1 was the formula, no? N2 was for what? If you go to the previous slide, see this. N2 is the refractive index of the medium where the ray is going, and N1 is from where the ray is coming. So N1 is for object. Okay. So N1 is for object. Object यहाँ पे कौन सा? Object is the bird. Okay. So we'll write here N1 value equals to 1 now, and N2 value equals to 4 by 3. So simple. 4 by 3 upon 1. Apparent height is how much? H dash. Real height is 36 centimeter. Solve this thing, you will get H dash value is equals to 4 by 3 into 36. This is equals to 48 centimeter. So I'll say like this. From the boundary separating two mediums, I'm getting the H dash value from the boundary separating two mediums. MM dash is the boundary separating two mediums, water and air. H dash value is equals to here 48 centimeter. Okay. Answer here will be what? 48 centimeter. Got it? Okay, students, answer here will be what? 48 centimeter. I hope it's clear. I hope students it's clear. Yes. If you want to see with respect Okay, so I think I'm audible now back. Okay, is it fine? Today, students say some network issues there due to some inspection thing. Okay, so I hope now it's audible clearly. Okay, no need to worry. What we'll do is that we'll solve this question. I'll be solving. You need not have to do anything. After this, we'll start a fresh topic that is critical angle. Okay, then we'll end the class. So at least for these few minutes, be focused. Okay. So see here, I'm solving this question. See, this question was cleared in the previous class. Maybe I've solved in your class. If it's revision is required, it's fine. Otherwise, we'll proceed for the critical angle. What do you say? What do you say, students? Is the revision required for this? Otherwise, we'll move for the critical angle. This question was solved. If it is solved, then it is okay. Otherwise, we'll move for the critical angle. Please text in the chat box. Okay, one of the students have texted me. That's good. Achha. So Sneha says, sir, move. Okay, so AP says move. Okay. So Nalibot says moved. Okay. Okay, so you want me to move next. Leave this revision of this topic, Hannah? What about other students? What about Anshuta, Akansha, and all this? Sonali again? No? Okay. So I'm moving towards the next now. Have we completed shift in your class? Did you understood the shift? What was the shift thing? I've explained in your class this much. This formula, shift. Okay, tell about the shift here. Shift में क्या था? What do you came to know about the shift? Comment on this shift. Any one of you, shift. Okay, I hope the shift is also completed in your class, है ना? So this was a question. It was very easy question. It says thickness of the slab is 15 centimeter. Refractive index is 1.5, and this slab is kept in air. So of course, the surrounding medium refractive index will be 1 here. Acha. Sneha says slab wala nahi. Okay, so let us see the slab now. Okay. So let me move back. So now write the heading, students, in your notes. Write this heading in your notes. Apparent shift. Nick, just text in the chat box. Ki, if this is completed, sir, we want the revision again, or sir, leave this, like move the next. It's as per your convenience. Okay. Write this heading in your notebooks. Apparent shift due to slab when the object is seen normally through the slab. So I'll explain you what to do and what's the formula is and all these things. So at least you are able to solve the numericals. Got it? So before ending, we'll complete this lab shift. So suppose the object is in front of you here. This is the object's location. I is here. This is I. I means you're observing. This is the observer. See, O for object, O for observer. But the things are completely different. See, this is the ray diagram which is drawn. There is no need of derivation for this. Suppose a ray is passing from the object like this. There is a slab of thickness T which is having refractive index mu inside. And this glass slab, suppose this is glass slab or some slab or of some material. And this slab of thickness T is basically kept in air. So we'll say the surrounding medium is what? Air here also. Same air here also. Same air here also. So when the ray of light passes from this object, it meets here. It is passing from a rarer to the denser medium. So it will bend towards the normal. Again, when it will pass out from denser to the rarer medium. So when the ray from this object is passing via this through this slab, it is getting refracted 2 times. One time it is here, second time it is getting refracted here. So the final emergent ray, suppose the eye is here, it's shown here. Suppose the eye is here now. It would draw the eye here. When the final emergent ray reaches our eye, we'll say like this that the object's location when extended back will be here, which we you know is O dash, which you know is fake, and we know the original object is here. Okay. O is this, O dash is this, which is fake thing, which is the image of the object. So we say shift is how much? Shift is from O to O dash. This is shift. Remember always. Shift will be from O to O dash S. Okay. So we will say like this that the object appears as if it has shifted with magnitude, which is S. Okay. First of all, tell me before writing the mathematics, the object's rays after the second reflection when reaching our eyes extended back shows the image of the object O dash, which is actually the fake. This much ray diagram is it understandable? Yes or no? Text here in the chat box, students. Yes or no? Very good. So I hope one of you got, yes, Sneha got understood. Okay. So now let us see the mathematical formula. So mathematical formula is this. So you can see this is for air. If the slab, it's not compulsory to write this glass slab, but I can write just simple here. If some slab is kept in air, okay? So you will write this formula where T is the thickness of the slab, mu is the refractive index of the slab. T is the thickness of the slab, mu is the refractive index of the slab. Okay? But suppose if the medium in which the slab is kept is not air, so you see we know this thing. अगर ये air होता तो for mu of air is equals to 1, we will what? Flip back. So again you will get the same formula. But if this is not the case, we will write a random general formula which is this. That is shift is equals to thickness of the slab 1 minus mu of the surrounding medium in which the slab is kept divided by in the denominator mu of the slab. This is the formula. Remember it. So I will say if the thickness of the slab is given and that is given that where the slab is kept, by using these values I will get a shift. So shift will give me what? That the object, suppose it's actually fake thing, you know, we know that O dash is the image of that object, like when we see from the other side of the slab. So we'll say this is the shift, as if the object has shifted to O dash location, but actually this is, it hasn't shifted. What happened is this, we are able to see it, you know, when we are standing on the other side of the slab, where it appears to our eyes that the object is now at O dash, and we call it a shift, but actually it is not happening. We know O dash is the image of the object. Okay. So I hope you understood both the physical significance and the mathematical formula. Is it right or wrong? I mean, did you understood or not? Students, did you understood or not? Yes or no? Write this notes in your, write this formula in your notes copy and text me in the chat box to proceed next. Okay, Sonali is fine. Sneha is. So importance again. I'm highlighting the, see, for the shift also, take as first point, fast, next. Medium on the both side of the slab should be same. So it must be like this. Okay. Whatever the slab which you're using, the slab here, suppose this is a glass slab of glass slab, I mean, this must also have some thickness T. If this is glass slab, it will be having mu equals to 4/3. If it is kept in air, everywhere it will be mu1, 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 mu1. Surrounding medium will be same always. Okay. So it must not be like this. Here you are keeping oil, here you're keeping air, here you're keeping gel, here you're keeping something else. That's not a thing. That's, I mean, that's not a way we'll solve this. I mean, this theory we haven't studied, no. So this formula of the shift, that is T1 minus mu of surrounding, is everywhere in the 4 directions upon mu of slab. Okay. Shift comes out from the object, that you can see yourself. See, because when the slab was here, and the object is here. It gets shifted like this, so it comes out from the object. Okay, it comes out from the object. See, if the shift is positive, then it is towards the direction of the incident rays and vice versa. So now here also we'll put the sign-in convention. Let me explain you this on the slide. Sign-in conventions will be like this. Suppose you take a slab having the thickness T. If mu is the refractive index of this slab, if the object is here and you are observing the object from your eyes here, so you will see like this, that the object is shifted either here in this direction, which is also out direction, no, that is S, which whose value you will get as positive. If mu surrounding is the surrounding, mu surrounding is what? It's a refractive index of surrounding medium, suppose. And if you see like this original location of the object is now here, O dash. So again you will say shift, but the value of the shift will, you will see that numerical value के साथ negative sign will come. Okay, negative matlab your observation is this ki object is far away from the original one, and positive matlab if we do interpretation in physics, we'll say location is near. ठीक है, got these things, positive and shift negative. This is for shift negative, this is for shift positive. Is this thing clear, students? Yes or no? If this thing is clear, then we'll solve a question and we'll end the class. Yes or no? Very good. So students, solve this question. It's in front of you. See, this is a class illustration. It's important, you know this thing. Okay, you want me to solve this? To repeat it, okay, I'm telling like this. See, listen here carefully. If this is a slab of thickness T, having refractive index this, and mu surrounding something mu equals to say mu dash is the refractive index of the surrounding medium. So if you see object, this is object here, if you observe it from here with your eyes, if the shift comes positive, it means the location is here. If the shift comes negative, it means the object is here from the original position. So these are simple sign-in conventions. Is it right, Sneha? I hope it's clear. That's good, okay? So now let us move towards the question fast. Solve this question, students, by using the formula shift T1 minus mu of the surrounding upon mu of the slab. Thickness of the slab is 15 centimeter. Refractive index is 1.5. Okay. And surrounding medium, it's given as air. You can read yourself. Calculate the shift produced by the slab having thickness this and air is this. Air surrounding medium ka refractive index will be 1. Apply the formula. Okay, very good, Sneha, if it's cleared. So tell me whether the shift will be positive and negative. If positive, where it will be, negative, where it will be. Okay, I am solving for you. See, this is the first question, so it's like this. Slab, thickness kitna hai? 15 centimeter. 1 minus mu of the surrounding is air. Mu of the slab is 1.5. This will give you 2 by 3. Net answer will be 1 by 3. This comes out to be positive value. So I can say like this. If the slab is kept in front of you like this with 15 centimeter thickness of the glass, that is 1. Suppose some material say mu, okay, and the object is actual location of the object is suppose this. Actual location of the object is suppose this. So shift comes out to be, if you observe from here, you will say that the object is here, and we know the shift is equals to how much actually? It's 5 centimeter positive. Negative is that direction. Very good, Sonali. Okay, cool. Now let us see a last question based on the shift. See, this is the question. Are you able to solve? Okay, I'm solving this question. This is a good level question. Note it down. Okay, this is a very good level question. I rate it as 3 star. Okay, 5-star rating. So I'll solve, just focus here. Okay, it is based on shift only. See, it's given like this. Velocity of the light in quartz is this. So right, see, whenever you solve a physics numerical, write all the things side by side fast. Okay, so it's given here velocity of the light in quartz. Quartz is this, some material found in the nature. 1.5 into 10 to the power 8 meter per second. Then they say like this, velocity of the light in glycerin. So now we'll write here velocity of the light in glycerin. 9 by 4 into 10 to the power 8 meter per second. Then they say that now a slab made up of quartz is placed in the glycerin as shown. So of course, from this information, we can conclude like this, that mu of the surrounding medium is equals to the mu of the glycerin, because the surrounding medium is here glycerin, and mu of the slab is here for mu of the quartz, because the slab is made up of quartz material. Okay, so they're asking the shift of the object produced by the slab. Of course, if the object, see, object can be in any side. We have seen the derivation when the object was here and the observer was here, but now it's reversed. But the answer will be same if you see from this side or that side. Okay. Suppose we are standing now on this side and the object is there at 20 centimeters. So see, whether you keep it at 100 centimeter, it's nuisance. I mean, it doesn't make sense. Nonsense. It doesn't make sense. The reason is this: key shift is with respect to its present location, not with respect to the distance from the side of the perpendicular side of the slab. Okay. So we can write here like this. Shift formula we know. Let me solve on this slide. Thickness is 18 centimeter here. Okay. Let me give you the solution. So say the solution is this. Shift is equals to 18 centimeter 1 minus mu of surrounding medium is glycerine. Mu of slab is quartz. But we are not given these values. But we are given what? We are given the velocities here. Okay. So I'll apply a new formula which you have studied in the beginning, that mu1 upon mu2 is equals to v2 upon v1 equals to lambda 2 upon lambda 1. Okay. So from this we'll take only this part, that is equals to this. Apply this here now. So I can say like this. What I will write like this here, that mu of glycerin upon mu of the quartz can be replaced with this, that is speed of the light in the quartz upon speed of the light in the glycerin. Because you know, if this is 1, the down will be 1. This is 2, the up will be 2. Similarly, this is glycerin, this will be glycerin. This is quartz, this will be quartz. Okay. So the formula becomes now 18 thickness minus V of the quartz, speed of the light in quartz, upon speed of the light, speed of the light in glycerin. So now write the values and get the answer. 1 minus how much it is? Speed of glycerin is, the speed of quartz is 1.5 into 10 to the power 8. इसमें 9 by 4, 10 to the power 8. So quartz में 1.5 into 10 to the power 8. Glycerin में 9 by 4, 10 to the power 8. Okay. So through this you will get the value as this. 10 by 8, 10 by 8 cancel. This is 1.5. Okay. So I will say the value will come out to be 18. 1 minus 1.5 is basically 3 by 2 into divided by how much? 4 by 9. 3 3 is 9, 2 2 is 4. This will give you 1 by 3. Shift as equals to 6 centimeter positive. Okay. Very good. Sonali have given the excellent answer, right answer. Very good. Study well. Okay. I mean, so all of the students must give the answer. What about Sneha? What about all of the students from JNV, Raipur and all? Okay. So answer we got here is 6 centimeters. So I will comment like this on as per the slide. I'll say if you are able to see the object. Okay. One more student have texted. Same answer. Very good. Sneha, same answer. So if the object is here, whether it is here, wherever, okay. So with respect to that location, because since the object shown here is at this position, this. So shift is positive. Positive matlab towards the observer. Okay, means positive direction. So I will say 6 centimeter will come out to be here. So you will find out this person observer on the other side will find like this, that the object is here towards it. And if you draw the ray diagram, see again what's going to happen. Denser to rarer, sorry, rarer to denser towards the normal. Again coming out away from the normal. So if you draw it back, you will get image here. Okay. So this question is completed now. In the next class, we'll see critical angle. See, as per your demand, this slab revision is again cleared. If it's not happened in this class, I've completed now the slab topic with the 2 questions. Okay. If you're having any doubt, you can text in the chat box. So that was all about today's class, students. Bye bye, everyone. Take care. We'll meet in the next week. Study well, work hard. You can refer HCV. You can refer the HCV. Okay, I will upload the notes. With that, I will upload HCV book also there, PDF soft copy. I hope you are having the hard copies. I'll try to upload some material of ray optics there, printed material of different famous institutes. Okay. Maybe if you want, you can text on the chat box. Okay, students, we'll meet in the next class. Bye bye, everyone. Take care. If anybody is facing any doubt, you can. Okay, students, so I'm providing you the NPS here. Please participate in the NPS. Bye, everyone. Okay, bye, Sneha. Bye, Sonali. Bye, everyone. Participate in the NPS here and you can leave. Okay. Okay, so students, bye bye everyone. I've ended the class.